Okay, we're going to be doing a t-test of a mean. And so I think of this as you're trying to compare what you observe with what people are expecting. So in this example, this is what we are expecting. I read somewhere that the average Grandmaster has an APM of 140 actions per minute. So that's what I'm expecting. But we just had some data here in GeoGebra of Grandmaster players. So I'm going to test, based on my sample of these Grandmaster players, is this a significantly higher average, or is this nothing significant? And so the difference here is I can actually just look here at the average here. The mean is 158. And I could say, well, that's higher than 140, but because of random chance, because of different things, is that significant? Just because I have a mean of 158 does not mean that there's something weird going on. It's just like if you roll a die and you get 3 sixes. That's improbable, but it might just happen by chance. So the t-test is testing, is this significant? Is this really something out of the ordinary? And so here's what we need to do. We need to set up our hypothesis. In our H0, this is called our null hypothesis, we always assume the benefit of the doubt. We're going to say that the averages are approximately equal. Okay, now we're seeing different averages here, different means, but we're saying statistically there's no real difference between them. Just because one's higher for this observation doesn't mean it will always. Maybe on average we would get about 140. The alternative is what we're really wondering. Is the average that we observed greater than the average that we're expecting? And so I probably shouldn't write an is. I'm just going to write this statement right here. So we would take that, drag it over. So we have two hypotheses to choose from. Our test is actually going to check the null hypothesis. We're going to see, are they equal? Now, if it passes the test, then we do not reject it. We just say, you know what, there is no real difference. But if we have to reject it, if the test fails and we know that there's something going on, then we reject this and we would go with, you know what, actually it is larger. And so the mean was 158 that we observed. The mean that we're expecting is 140. Let's check to see if that's significant. There are a few other things that we need to know. One thing is called the alpha level. For our class, we're going to use an alpha level of 5% or 0.05. This means basically we are 95% sure when we're doing a test. Okay, that's important. For the S here, we can do that with GeoGebra. Our S here is 36 point, we'll round to 6. 36.6. And then the number in our data for this one is 9. And let me say once more, when you're doing your tests, when you're doing your analysis, you want to have something like 30 to 40 if you can. Okay, we're going to be 95% sure with this data to test and see, is this relatively expected, or is this out of the ordinary? So here's what you do. You get all that information, you write it down, and then you go click on this little triangle and go to probability calculator. Alright, now I already have it selected, but you might start here. You have to click on the statistics tab. We're going to do a t-test of the mean. Alright, so here's the expected. That's what we expect. The alternative is, well, we found that we have 158 with a standard deviation of 36.6, and I already put these in, so that's why they're already in there. And we want to think, is 158 greater than that? Okay, so it will calculate for you automatically, and here's what we get. Alright, now this is just stuff that we'd figure out with the, if we were doing like a full stats class. This is the key. P is 0.0892. P p equals 0.0892. As a percent, that's 8.92%. Now, that means that we are actually outside of the 5%. If this is smaller than our 5%, then we can conclude that we would reject H0 and there's something weird going on. But because this is larger than 5%, we would say that we fail to reject H0, which means basically we have to accept this hypothesis as true. Even though this 158 was larger than the 140, and it looks a lot larger, it's actually statistically pretty likely that if we just go take a random sample that we would get something like 158. It's not that out of the ordinary. Okay, so let me say this again. If we got a p-value that was smaller than our alpha, we would reject this and we would say, oh, okay, there's something weird going on. It actually probably is much higher. So either the average, if that was the case, either the average we're expecting is wrong, or there's something special about our sample. Okay. So again, this is if you're testing a mean and you're comparing it to what's expected.